Okay, guys, so let's start. So this is our PortaiNerd, as you know, a 10-part webinar series where we demonstrate several how-tos. So in this how-to series, we're in webinar episode 6, how to manage containers at the edge with Portainer. Portainer has a very interesting edge management engine that I'm going to demonstrate today. So in this episode, you will learn how to manage containers at the edge with Portainer. And the three main nuggets of wisdom that you should leave with is setting up edge agents and devices, organizing edge groups, and deploying edge stacks. And if there's time, I'm also going to show a beta feature that we have, which is edge jobs, which I think I will have time to present, which is also very, very cool. Okay, my name is Adolfo Delorenzo. I'm a tech evangelist with Portainer. Here are my contact infos if you want to connect with me via LinkedIn, email, or if you want to set up a 30, 45-minute or 1-hour chat with me, you can go into my HubSpot calendar and check the available dates, hours, and set up something. I'd be delighted to talk to you and have a conversation on Portainer and the future of technology. And here we have Michael Cooper, our product engineer, our product guru, and wizard. He will be helping us with questions and answers. His contact information also here, so please feel free to contact any of us too for further inquiries or just to chat if you would like to, which I also enjoy a lot. Let's go to my screen. So here I have, as you can see, two virtual machines. These virtual machines are, let me just close this one. These virtual machines are simulating edge agents, and I'm using my computer with an x86 architecture, and I have another two edge agents, which are real ARM 64 machines. So I'm logging into my Portainer instance, my Portainer lab instance here. And this time I am running Portainer on a Kubernetes node. I'm not using Docker this time, just to show that it's also the functionality. If you were running this on Docker, Portainer on Docker, or running Portainer on Kubernetes, the functionality is exactly the same, identical. So there aren't any changes when we talk about using Portainer in Docker or Kubernetes. And here I have these two ARM edge nodes that I'm calling. One is a Raspberry Pi 4 with 4 gigs, and the other one is an N2 Odroid. It's a Korean-made ARM device. Really nice. I really like this little board. It's extremely fast and it's really robust. So this is to show that we can add, and this is real hardware, right? Real IoT devices at the edge. And these other two edge devices are the ones that I mentioned before, which I'm virtualizing. And I'm going to start with explaining what is an endpoint. Okay, so we have several types of endpoints in Portainer, and each one you can connect to in a specific manner. So the traditional Portainer agent is something that you're going to use if you have a stable connection, if you are on a LAN or network or a stable network, even if it's a VPN, but you have direct access to the instances or the endpoints, clusters, machines that you want to connect Portainer to, right? So the reason is that this agent has a synchronous or a point-to-point connection with this Portainer agent running on a remote on a machine that is running on your network, and well, without that, you would need something that can run on a less stable network, and you can consider a less stable network something that is running on a dish, an antenna, satellite, 2G, 3G, 4G. I mean, remote in a sense that you don't have, like what happened to me last week, a stable connection. You don't have a guarantee that this connection is always up and running for you. And this is really the case of IoT devices that you have spread around a huge geographical area, region. It can be a factory, it could be an airport, it could be a hospital, You can have situations where your IoT devices are for some reason offline, and this is when you want to use the edge agent. So let's put it in simpler terms. If you have a stable internal connection, go for the traditional Portainer agent. If you have an external, unstable, unreliable connection, or even a slow connection network, go for the edge agent, right? These other three are for Docker if you're running Docker locally on the machine that's connecting to Portainer. Same thing for Kubernetes, which is the case today where I'm running Portainer. I'm running this on a local Kubernetes node. And this is for when you're running containers on the Microsoft Azure ACI service, right? This is not relevant. These three are not relevant for us today. Well, actually, the only one that's really relevant is this edge agent. So my endpoints here are all connected, as you can see, via edge agents to my main Portainer instance. Now, how do I activate the edge capabilities of Portainer? That is very easy. All you have to do is you have to go to settings and you can enable the edge compute features. As soon as I click save, you'll notice that there's now a new menu here called edge compute, right? And this is where the nice magic starts. So I'm going to delete these edge groups. I'm going to redefine them so you see how it works. So now we're going into, we've just saw edge agents endpoints, and now we're going to see edge groups, how to create edge groups and what is the importance of creating edge groups. Okay, so I have 4 machines and I have 2 technologies, right? ARM devices and x86 devices. These are the CPUs that are running on these machines. So I'm going to create a group called ARM 64. And there are 2 ways of creating groups. Statically, where I just click here on the machines, right? And I define a group. This is easy when you have a small amount of IoT devices. A Portainer can, on one instance of Portainer, manage up to 20,000 nodes, IoT nodes. So if you have loads and loads of IoT devices being managed by your Portainer instance, you can't really do this manually. You can use a feature which is called the dynamic group edge group creation, which will use parameters that it will match to against your IoT nodes or edge devices to be able to add them to these groups that you're defining. So I want to make sure that it's an ARM device. Right away, I can see that it adds these 2 machines, right? Or if I want a partial match, again with ARM device and at the edge. Okay. Oh, well, if I add the edge, my x86 machines come up. So this is not good. So what is the difference between partial and full match? As you can see, full match is the same thing as and or when we use conditional programming, right? If you, it has to be this specific condition and this other specific condition, and so it always has to match fully the conditions that you're putting here to create the group. This is why it's called full match. Now, partial, it can be and or these conditions, and this adds machines that I do not want added to this group. So in this case, I want a full match. So it really depends how you organize your IoT machines or your edge devices to be able to use one or the other. In this case, I'm going to use the full match because it does what I need. So I'm going to add 2 ARM64 devices to the ARM64 edge group. Okay. And I can see here the edge endpoints count. Now I'm going to create another one called x86 or AMD64. The reason why I use x86, because the instruction is similar and not AMD64, is that ARM64 and AMD64, they're very similar, right? If you have a huge amount of machines or whatever other name you want, if you don't want to use the architecture as the definition of the group, it's fine. But if you have to, it can be a bit confusing. So I use x86, that I know it's an Intel type CPU running on these edge devices. The same thing. I'm going to use dynamic, full match, x86, and edge. Right. And I have other parameters here. I could say if it's local, I'm only going to get one because only one of the machines I have tagged as a local machine. I'll soon show how I organize this in terms of tags. I don't want local. Okay. And edge group. We have two groups. So you go, how do you do this magic, Adolfo? Well, it's very simple. When you define endpoints, you can create tags. And here are the tags I have defined. ARM, Edge, Local, and x86. Let's say I have machines running on a VPN, or these are really remote. I would have remote. Let's say I have them in a south east region, right? So the definitions of the tags they are really open for you to define, and they will preferably would follow a logic that makes sense to you in terms of how you're going to group these devices, right? So these tags are the way are the tags help you with the endpoint group definition, right? So this is how this little edge group magic happens. So let's say I have um, again dynamic machines, and I say okay southwest, northwest, northwest remote. I don't have any of these machines defined here, but I'm going to create the group anyway. Northwest, call it remote, and you'll see why very soon. Okay, so I have three groups, two with the architectures and one with another type of definition, which is a geographical definition to the name of the edge group, and it's also based on tags that point to geographical references, right? But again, the references can be anything. You can have a tag that says dev or production or I mean, these definitions are open for you to define. Right. So this is how we define edge groups. Now I have to refer to um let's see stacks. Right. Okay. So let me just do the following. I have to close some windows and go to some of the stacks that I have already written down for this demonstration. Let's see. Okay. So let's say that I'm going to create now a stack. What is the concept of stack is, and in this case, based on Docker Compose. Even though, yeah, you want to make sure that you use the Docker Compose file format or the Compose file format to deploy this. And it starts by giving a name to the stack. So I'm going to start by calling the stack caddy, which is the image I want to deploy. And I want to make sure that caddy is running on the ARM64 devices only, right? And for that, I have I'm going to copy paste here, a very simple Docker Compose file that basically pulls the caddy image, pushes them to these ARM devices with some definitions of the restart definitions and the ports where it's going to run. Okay, with this, I can deploy the stack. And here I have a visual representation of three things. If the stack has been acknowledged, if the stack has been successfully added to the endpoint, or if there was a failed endpoint in terms of receiving or let's say deploying the stack. Okay. So if I refresh here, I see that at least one endpoint has already received the stack, and the other one has already successfully deployed the caddy stack. I can also click on auto refresh here and keep this auto refreshing every 10 seconds. But because I'm impatient, I'm going to do this again. And I see that one of the endpoints is still receiving the stack. And the error could be, and then you have to really go into the endpoint and see if there is an error, why there's an error, and how to fix this error, so on and so forth. So in the meantime, we only have one device with this stack deployed. So this is interesting because you have a very quick and easy way to understand and see which of these edge devices have received the stacks properly, and which ones haven't, and how you can fix these. All right, so let's go to oh, this is the reason why the endpoint did not receive the stack because there's something wrong with the heartbeat of this endpoint. So now I know why. As you can see very easily, I can understand a potential reason why this edge device did not receive my stack properly. There's a heartbeat problem here with it. If I go into the one that I believe has received the stack properly, which is my Raspberry Pi 4, and the edge point connection is not, let's say, real time. It has a polling moment and that you can define if it's 5 seconds, 10 seconds, or 30 seconds. And I'll show you quickly how that can be done. I can see, okay, that the caddy image stack has been deployed successfully on this machine. And hopefully, if I click here, yep, as you can see, caddy is running successfully on that machine. Edge device, if you may, but it's still not running on my N2 because I have probably have a little issue with my N2 device. So as you see with this, very quickly, you can debug issues. I'm having a connectivity issue, and this could be the network is down, the machine is down, but very likely it's a problem with the network because again, the edge device is was conceived in a way that it can run on unreliable networks. And I'm simulating a network error, right? This is actually, I did this out on purpose. This is not that just happened by mistake because I wanted to show that how the edge agent works. Um, it's not receiving a heartbeat from the N2 device, so therefore it won't be able to deploy the stack until this problem is fixed. Okay, so now let's add a second stack, which I'm going to call the MySQL. And I want to make sure it runs on my x86 machines. Same thing. Now in this case, I have a composed formatted file that is going to deploy the MySQL server on these machines that are part of this group. Deploy the stack. And again, I can monitor here with my uh, um, color-coded little bullets what is going on. I know that 2 of these machines have acknowledged the stack, and they're still acknowledging the stack. And hopefully they're going to start running MySQL very soon. The reason why it might take slightly longer is because I configured these 2 machines as with very low memory. I think they have 512 megabytes. It's less to really simulate an edge device, right? And let's see, this host has oh no, it's actually got 4 gigabytes memory. So very soon we should see the stack being deployed. Let's see. Okay, again, one of the machines has already received the stack. Let's see if I have an error in any of the 2. Nope, they're fine. Let's see which one has already received it. Okay, so Edge 1 received the MySQL stack properly. It's up and running. If I click this, it won't take me anywhere because this is a port specific for this device. But a way to access this container here is to go into the console, and I can connect to this MySQL application running on this Edge device using the console within Portainer without having to use a external shell connection or any of that type of, or a VPN connection. You can directly within Portainer connect to the application. It's similar to the Docker exec -it, then the command or then the application, and then bash bin dash bash, for instance, right? But instead of having to write that huge amount of code or having to memorize that all the time, you can do this with directly within Portainer. And the functionality of the Edge device, Edge agent, is exactly the same as a regular Portainer local or Portainer agent, meaning you can do everything that you could do if you were running this locally on that device. Exactly the same. And again, the difference is just the way it connects to the Portainer instance. Let's see if that second stack finally, oh, okay, finally got deployed on the second device. So we go into Edge 2, and we see that this container is up and running also nicely on this Edge device. Okay, there it is. It's up and running and nice and healthy. Let's see if this host has also 4 gigabytes. So it's a sort of a robust machine. Um, and again, this doesn't have to be necessarily only for edge devices, right? I mean, in the sense that it's I better said only for IoT, small inter or limited hardware devices, right? It was done in a way where it can run on like very modest machines with little memory, and with not very fast CPUs like is usually the case of these IoT devices. But you can run this on large scale servers. And again, if you have a server, let's say you have a factory, right, and then you have a remote factory in a region wherever that is that has very poor connectivity. You can only access this factory via satellite connection. There's hardly any cell phone coverage, but you need to manage the hosts that are running in this factory. This is where you can also use an edge agent, right? And there are other. If you watched the episode on team collaboration, you will also see other ways of using the edge agent with Portainer. So I invite you to go into our channel and check our team collaboration um, episode that shows other interesting ways of using the edge agent with Portainer. Right. So we saw the edge groups, the edge stacks, and edge. And now I want to show you edge jobs. Right. Um, so the edge job is nothing more than a script that you can add to the edge agents that you might want to have running in a periodical manner, and then you can use the basic cron rule to define how you want to run this script. You can upload the script, and you can use the web editor. Let me see if I have a script here. I think I do. I should do. I should have some. Uh-huh. Right. I think this is going to work. Let's see. So this script here, and I'm going to add to this device, which is my Raspberry Pi 4 device, is basically using Gotify. Gotify is a event server that you can run on your cell phone. You can run on your machine that basically receives messages via an API and replicates and shows these messages on wherever you're running the Gotify client. So I'm going to add this to the RPI machine. I'm going to call it, in terms of cron, let me see. I think, what is the cron definition for every minute? I think it's, let's see. I want to run every 3 minutes, otherwise I'm going crazy. No, this is not. Sorry, guys, I'm doing a search here on a different browser that you can't see every 5 minutes. I still don't know this by heart. Shame on me. Okay, every 5 minutes. Right, so this is the cron rule for running the script every 5 minutes. Actually, I'm going to leave it every 3 minutes. Right. Okay. You know what? Every 2 minutes. Otherwise, it's going to take too long. So I create this edge job. And now I have, a connection error. Let's go to my Kubernetes instance and see if I have my Gotify server running. Here it is. Gotify running. There's a port mapping. That's 3. Okay. So now I'm going to open Okay, so if everything works, my Raspberry Pi should start sending messages to my Godify server, and we're going to see these messages here. It said that there was a connection error. Let's see, what was this connection error? Results. What did I do wrong? Rollouts. Again, this is a beta feature, so sometimes it works, sometimes it doesn't. I'm sorry if it didn't, if it won't work. Let's see if my apps. Okay, the token is right. Oh, I heard a ping. There you go. So the script is running. So basically, the script is a message saying RPI4 is working fine, and the title of the message is RPI4 test. So probably when I deployed the script, there was a connection error, but the way the Edge engine works with Portainer is that it keeps retrying until it something happens, right? It will try until nothing happens, or there's an error, or it will try until there's a successful connection. In this case, it retried deploying this Edge job onto that specific device, and it finally worked. And now we have our RPI4 sending these test messages to my Gotify server, right? And it could be, you can define more devices. I can have my N2 device here also, or I can create one per device. So this is something interesting of this feature, which again is still in a beta version. We have more functionality that we want to add. As you can see, the Edge jobs need. We still have to add the group functionality to the Edge jobs, just like the Edge stacks, which we still haven't deployed. For now, we have to do it individually per IoT device. And again, if you have a huge amount of IoT devices or Edge devices, you're going to go crazy. So this is in a beta version, but it works very nicely, and it's in the roadmap to enhance this feature. Okay, now let's say finally I want to add another endpoint. So I'm going to spin up here. Let's see. I hope it works on this Edge 3 machine, also virtualized. Could I already add this machine to my environment? Let's pre-provision this machine. Oh, it's going to keep pinging here and drive me crazy. Let me just mute this tab. Okay, let's mute it. I just closed it. I want to add a third Edge device. Can I do that without the Edge device existing? With the Edge agent, you can, right? You can pre-provision machines, right? Meaning you can have, like, if you have, let's say an example, what this means. Let's say you have 10 devices and you know you're going to receive another 20 devices. You can pre-provision all of the devices in Portainer. And as they start being deployed and being connected to Portainer, Portainer is going to start adding them with a heartbeat, with a successful heartbeat or not, to the main panel, to the main Portainer instance. So in this case, I'm going to add this device, and I'm just going to go update endpoint, and it's there. But if I go here, it hasn't been associated yet. So now I'm bringing up this Edge agent, which I hope is already working. Let me show. Okay, here it is. I'm going to log into this machine here. Let me see if I can get an IP. It's easier. Yeah, 16. It's easier to use a terminal. Let me open a new terminal window here. The window. Okay, let me increase this font so you guys can see nicely. SSH root at 10.51.1.68. Okay, should work. Yes. Oh, this is a bit too big. So I'm going to add now this Edge. Let me see if Docker is running. Docker. Yes. Yes, I have Docker with no images there. So this is an Edge device that has Docker running. Could I use Kubernetes? Yes, I could have this running with Kubernetes also. And we have tiny Kubernetes node images that you can run, like micro K8s, the K3s, K0s. In this case, I'm using Docker, but it could run on Kubernetes also. So that means I can add Edge agents with Kubernetes. Yes, you can. And this is a Docker standalone. What you can do here is just copy the command, right? I know it's a Docker standalone. It would be the same for Docker Swarm, but then you would obviously want to select the proper command for Docker Swarm. But it's for all of these three, all you have to do is just click on copy the command. So it's the same procedure here in terms of you don't have to memorize this or retype this. Just click copy or copy. So in this case, I'm going to use Docker standalone, right? And I'm going to go here and I'm going to paste this. It's already adding my Portainer agent. It doesn't have the image on the machine, so it's downloading the image. Adding the image to this Docker instance, standalone instance. And okay, let's see, Docker PS, my agent is here, up and running. The IP of this machine, I think, let's see, 0. Yep, 1051.168. So I added this machine later to the game, right? But wait, I won't update this yet. I want to add an edge stack where I define, first I'm going to add, where's this edge group? Okay, Northwest. Let me update this endpoint. Let's see, what are the parameters? It's Northwest and remote. So this endpoint here, Northwest and remote. I'm going to update the endpoint. I'm going to go to the stack. I'm going to add this stack as Northwest remote. So I'm doing this without the machine being connected to the Portainer instance. Okay. I'm adding a stack. I'm adding an endpoint, but the machine is still not connected to Portainer. I'm going to deploy the MySQL database. Where's that? Sorry, guys. Let me just copy and paste here from my notepad. There you go. And I'm going to deploy the stack. So what's going to happen? Nothing's going to happen because the endpoint hasn't yet been defined. So let's go. Actually, there is an endpoint, but it hasn't been connected to the Portainer instance as yet. So I'm going to now add this Portainer machine edge agent to the main Portainer instance. I'm going to update the endpoint. It's already associated. So now you see that now this edge device has finally been seen and has been associated to the main Portainer instance. But I did this in a asynchronous manner. You wouldn't be able to do this with a regular Portainer agent, right? So I defined an edge endpoint that did not exist. I added a stack to this and to a group where the machines that were defined in this stack did not exist. Let's see if I in the group updated the group appropriately. Yep, there it is. I didn't even have to add it manually because I already had a full match definition of this group. And once I added this endpoint with these tags, the edge group automatically understood that this edge device is part of this group because it's using the full match, or it could have been the partial match definition of the edge group. So this is the importance of having your devices organized properly with tags, because it helps you, and the groups properly defined with these tags, because it's just a matter of adding the endpoints with the proper tags, and they're going to be automatically added to the proper edge groups, and the stacks that are part of that group are going to be automatically deployed. And as you can see, this machine edge 3 is now running the MySQL container, and this is the first time I'm connecting to it. So it takes some time until it connects to this edge endpoint. I mean, from this directly into it, I mean. And here I can see the containers, and here I can see the edge Northwest remote DB1 up and running. Okay, so I think we covered everything. Please feel free, anyone that would like to raise their hand and join us in this conversation, talk to us, ask questions directly here in the channel. This is the edge functionality of Portainer. I'm going to add you to the conversation. There you go. Ralph, thank you very much for joining us here welcome and fire on. What is your question, my friend?
Good session. I've been watching. I've been part of all the other five PortaiNerd sessions.
Oh,
So
thank you.
one of the use cases that I'm looking at, and PortaiNerd is 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 working out pretty well in this in for what I'm trying to do. The thing that in our company, what we're trying to do is we're managing the entire stack at the edge. Now, when I say the stack, it's not stack that you refer to. It's the entire stack, starting from the infrastructure, which is the hardware that is at the edge, along with the platform that runs on it, the operating system, and of course, finally the container orchestration platform. We're actually using K3s. Now, my
Okay.
question is, when we first looked at Portainer, the reason we looked at Portainer was for its capabilities around application management, the deployment of applications and management of those applications at the edge, at an endpoint like Kubernetes or Docker. But we are mostly interested in Kubernetes. So what I want to
Okay.
understand is can I use your APIs alone? Because we are building a SaaS portal of our own. We only want to use your APIs to be able to do application lifecycle management. So how does that even work today? Can I can I even attempt it? I would like to do a proof of concept of that and present it to my team. So yeah, yeah. Any thoughts on that?
Yes, let me share my screen and show you our API capabilities. Okay, let's go to
Good
the
question,
Portainer.
by the way, Bareth.
Yeah, amazing question. Thank you, Barath. So our API is it's very detailed. You can use from authentication, templating, management of images, edge, and edge management also. So if you want to manage edge groups, edge jobs, edge stacks, edge templates, or just the edge devices, you can do all of that using the API. And it's quite detailed. You can go into, just type in, I typed Portainer API documentation, and then the result is right there. The first result is takes you to our API documentation, and here you can see all the possibilities that you have in terms of edge management with our Portainer API. So I think this hopefully answers your question because pretty much everything I do on the UI I can do with the Portainer API.
Oh, cool.
Does this help?
This looks good. Yeah, it does. I'll look at the documentation and I'll try it out. Yeah. Thanks so much.
Perfect, perfect. No, no, thank you, thank you. That was a very good question. And when we're talking about large scale deployments, I agree. Sometimes if you don't want to use the UI or you just have to integrate this with another application system or platform, there's nothing like an API to help you make your life easier, right? So yeah, great question. Thank you, Barath. And may I ask, where are you deploying this? Is it in your company?
Uh, so we are looking at evaluating port in a deployment in a framework that runs in AWS.
Okay.
So we have EKS, AWS EKS instance, and we want to deploy Portainer there. We have a bunch of edge sites, which the devices are going to be installed and the platform, the cluster, everything be created. So all of that we are going to sort of take care of. Uh,
Okay.
the end user, our customer, they would actually log into our SaaS portal, which again would run somewhere on AWS or equivalent,
Okay.
and basically manage. So we're going to allow them to define what an application is because that's all we want them to worry about. They bring in their application, we give them the platform and the infrastructure and everything that they want to run their stuff on. So we expose a user interface. We have our own APIs,
Okay.
and we want to
Okay.
use Portainer as one of the actuators that manages the entire stack. So
So
yeah, that's where we.
Okay, and this is deploying applications on Kubernetes, right?
That's correct.
Okay,
It's so we've kept our edge sites. We want to keep our edge sites lightweight and headless as well. So
okay,
we're using K3s as the
right.
platform of choice. We're using embedded HCD that K3s very recently enabled support for. Yeah, a lot of optimizations in terms of how small the control plane can be on at the edge site and so on. Yeah.
Yeah. I personally prefer micro K8s, but I also have to admit that K3s is also great Kubernetes distribution when it comes to lightweight distributions. So it's a very good choice. Portainer runs anywhere basically. You can have any type of Kubernetes compliant distribution with Portainer running. Like I mean, there isn't any difference when you run Portainer in any type of Kubernetes distribution. I've already deployed Kubernetes on K3s, Micro K8s, Charm Kubernetes, Kind, Minikube. I mean, IBM Cloud. Maybe what you might want to check is a video that we've just released this week, if I'm not mistaken, on RBAC and Kubernetes. Because from what you are describing, and we have another of our PortaiNerd participants, if I'm not mistaken, he will do this something very similar. Um, uh, you want to make sure that the RBAC is well defined, right? And for that, you might want to take a look at that video. Let me share my screen again. Our RBAC engine allows you to define role-based access control. And we have several roles that are already predefined here. They're very similar to the standard ones that are usually defined in Kubernetes, right? Now, with something quite interesting, if you have several Kubernetes clusters, you have to define each of these per cluster, right? And you have to do that manually, usually. The RBAC, the Kubernetes does not have an RBAC engine per se that you can really manage the rows and the service definitions. I mean, it's there, but you pretty much have to do everything manually, right? And you don't have a tool within Kubernetes natively that can help you visualize which rows have been assigned to which users, right? And if you have several clusters, you have to do that per cluster. So you're going to have to run YAML, the same YAML definitions or YAML files, however you do that, on each of the clusters. And you have to have some sort of Excel spreadsheet or database where you can manage, what user is using which row. And if a user changes rows, you have to revoke that row and redefine the row into that given cluster, etc. So it becomes a mess. I saw an image the other day that defines very well, and I thought it was quite funny. RBAC with the manual configuration of RBAC. Let me see if I can pull it up here. So you end up with something similar to this, right? Visually speaking, you have tons of YAML files, tons of roles that you have to define, tons of services, and the next thing you know, you have to use some sort of Git server, be that GitHub or the Git server of your preference, GitLab, Bitbucket, I don't know, and store all these YAML definitions. And let me see, I have in this example, I probably still have it online. Let's see, Adolfo Delorenzo with my RBAC definitions here. We're slightly changing subjects here, but where is it? Oh, is it here? I thought I had it here. Let's see, RBAC. Right, there you go. So you have to define roles per user, first the roles per se, and then the roles per user. And then as the figure shows, if you have multiple users doing multiple things, you have to have multiple files. And if the user changes rows, it becomes a mess. The interesting thing about Portainer and the usage of the RBAC engine, especially if you're going to have several edge devices, is that you can define this once for each user, right? So let's say I have a user here I want to define. I'm going to call, oh, there you go, Jane, right? I want to add Jane to this endpoint here. And I want to say that Jane is an endpoint administrator to this endpoint. But Jane is also not this, well, let's say this guy. Jane is also a standard user on this device, right? So it took me literally, I think, something between 5 to 7 seconds to associate a user to an endpoint with a role already predefined, right? So this is maybe something you might want to take a look at. If you would like to also set up a call, one-on-one call, so I can show you a bit of the RBAC functionality, or if you just want to watch the video and talk to me later, please feel free. Because from what you're describing, I believe you will have this challenge very soon, and you might want to avoid our situation here of having tons of RBAC files being defined. Next thing you know, you're going absolutely crazy, especially if it's a large deployment, and even if it's a small deployment. I think that if you have like 10 users, you're already prone to being exposed to this type of confusion, right? So yeah, it's something you might want to take a look at. But again,
Sure.
thank you very much.
Thanks for the heads up.
Yeah, no, and thank you for participating and bringing up this amazing question of the APIs. The API is really a powerful feature that we have with Portainer that I hope you manage to use. If you have also any questions about the APIs, just let me know, and I'd be happy to help you with that also. Okay, will there be a cloud Google endpoint at some point? Okay, cool, yeah.
I told him that we were leaning that way and that it was in the works. Until then, I believe he can use an edge agent, but I'm not certain.
I mean, we do have Portainer as a plugin on Minikube,
right?
But in this case, as Michael suggested, you just can add a regular endpoint, and that is more than enough.
Right.
We are working in having specific, slowly specific deployments on these cloud providers. But for now, we're just concentrating on the Kubernetes distribution. So Portainer is a plugin for Minikube and Micro K8s. And soon enough, we will announce news on other major Kubernetes distribution where you'll also be able to deploy Portainer very easily and deploy the Portainer the Portainer agents also. Depending on what you want to demo, you might need a license, a business edition license, and we have trial licenses that you can use for these purposes, for this purpose of doing business edition demos or just playing around to learn to understand how the business edition works. So just let me know. This is my contact info. Let me bring up my contact info here again. Let's see. And again, here is my LinkedIn and email and HubSpot calendar contact information for anyone that would like to talk to us directly, or also with Michael, LinkedIn and email information if you have any further questions. And with this, I would like to thank you all very much for participating, and I hope to see you on our next PortaiNerd. We shall be sending the invites soon, and I hope to see you there. Michael, once more, thank you very much for helping me here with your amazing expertise and answering all these tough questions. And for those that have participated, thank you very much and goodbye.